Hello everyone, welcome to my YouTube channel Chemistry Lovers. So in this video I have shown you the hydroboration oxidation reaction. So first of all, this reaction is the process of the formation of terminal alcohol from terminal alkene via the formation of trialkyl borane. Here you can see this is propene, which is classical example of an terminal alkene, and from this propene, if we treat dibordane on it in the presence of THF, tetrahydrofuran, you know this is a solvent, and second step, the alkaline hydrolysis followed by addition of hydrogen peroxide, so we can obtain this propanol, which is terminal alcohol. So how will the reaction carry out? What is the mechanism behind it? So let us know the mechanism behind this reaction. So first of all, since alkene contain pi electron cloud within it, so again boron is electronically deficient species because it carry a vacant 2p orbital on it. Hence this alkene donates its pi electron cloud from the vacant 2p orbital on the boron center, and on the other hand, in order to fulfill the electronic deficient within the alkene system, the boron donates sigma electron cloud from this BH bond. I will see you clearly. This is BH bond. The boron donates its sigma electron cloud from its BH bond towards the LUMO of this alkene. So alkene donates pi electron cloud from the pi HOMO towards the vacant p orbital of boron at first. On the other hand, to fulfill the electronic deficient within the alkene system, boron again donates a sigma electron cloud from the BH bond towards the LUMO of alkene and gives this type of transition stage. The BH bond is going to be broken and CH bond is going to be formed. Again this CC pi bond break, CB bond formation will take place, and this is the transition stage. You guys should recognize this type of in transition stage. You will see also elimination reaction, right? So from this we can obtain this type of species monoalkyl borane, where this entire alkyl group attached with the boron center, and this step will repeated 2 times, and we can obtain this type of trialkyl borane, where these 2 hydrogen are replaced by the alkyl propene because this is the reactant like propene. So these alkyl group are replaced by these 2 hydrogen. So this is trialkyl borane R3b, and this trialkyl borane plays the crucial role in this case because from this further we can carry out the reaction in alkaline medium. Hydrogen peroxide present in alkaline medium so give hydroperoxide ion OOH minus, negative charge present over the oxygen atom, and this negative charge donates towards the boron center because boron contain a vacant p orbital over it and gives this type of system. Since boron is small atomic element, hence it will not tolerate excess electron density over it. Thus from the among 3 alkyl group, one of the alkyl group will shift it from boron towards the adjacent oxygen center in order to remove the negative charge over the boron center. Hence in this way it will form this type of species, and this process again repeated 2 times and gives triester of boric acid. This is the triester of boric acid, OR. Again 2 mole of hydrogen peroxide, 2 mole of hydroperoxide ion required and gives similar 2 step repeated, and this type of triester form. If we hydrolysis this type of compound, then we can obtain our desired alcohol, where R is, you should know R, this is the alkyl group, entire alkyl group CH3 CH2 CH2. This is ROH, that is this, because our reactant is propene, hence this is our R, that is alkyl group, and propanol will be formed as a product. So it is a process for the formation of terminal alcohol from terminal alkene. Propene to propanol is converted. This is a conversion mainly. So here the main role played is trialkyl borane. The trialkyl borane is also famous for the formation of ketone, formation of alkane from several process I will show here. You can see application of hydroboration oxidation (HBO). Hydroboration oxidation is majorly is the synthesis of terminal alcohol from terminal alkene. I have shown you the mechanism, entire mechanism. Now besides this, we can also obtain several type of compound like ketone, like alkane from this trialkyl borane, right? How? Let us see. So first, formation of ketone. This is alpha halocarbonyl compound. You should recognize this is carbonyl center, and the alpha position here contain an halogen group, bromine or chlorine. And if we treat it with base, then this hydrogen will be captured by the base because it is acidic. Why? This is carbonyl centered, electronically deficient, so drags out the sigma electron cloud. Again, halogen, due to its more electronegativity, withdraw sigma electron cloud. So this hydrogen of course will be acidic, captured by the base, and the negative charge over the carbon present on this in this fashion. Here base can be hydroxyl ion, OR minus methoxide or alkoxide ion, right? Now what will happen? This negative charge over the carbon atom attack similar fashion over the vacant p orbital on boron center, because boron is usually electronically deficient side, right? Because it will contain a vacant p orbital over it, and this type of species will be formed. Again, in order to remove excess electron density over the small boron atom, an alkyl group from the neighboring position will shift from boron and attach with the adjacent carbon center, and on the other hand halogen will remove as a leaving group. In this way this species is formed. If we treat any Lewis base on it, like ammonia, water, it is also Lewis base. So again this Lewis base will be bind on the boron center, because boron is electronically deficient. Hence this Lewis base again bind with this boron center, and negative charge over the boron will be seen. And again this similar case, this entire group will remove as a leaving group, and further on the application of acid we can get this ketone. So in this way we can obtain the ketone from trialkyl borane. Here R can be any alkyl group, ethyl, isopropyl, isobutyl, tertiary butyl, any kind of alkyl group we have taken. Similarly, alkane also be formed. Here you can see formation of alkane from trialkyl borane, R3b. How? This is the carboxylic acid, and the carboxylic acid, the oxygen at the carbonyl center attack on the boron center and gives this type of adduct. Again the negative charge present over the boron, which is mostly destabilize the system. Hence an alkyl group from neighboring position will shift from boron center and capture this hydrogen because it is acidic, and gives the alkane in this type of system as a side product. Electrophilic center having vacant 2p orbital I have written also here, so that you guys will be understand this mechanism clearly. Boron is electrophilic center because it will carry vacant p orbital over it. Hence, in presence of any Lewis base or any negative carbanion species will easily bind with this boron center. So up to this, if you like this video, then don't forget to hit the bell icon, and if you are interested in organic chemistry, then please share with your friends. Thank you.